All right, good afternoon, one and all, and welcome to my course From Zero to Hero in Writing Elasticsearch Queries. My name is Somil Shah. I work as a software engineer at JobTarget. Over the years, I have been working on, for about nearly a year, I have been working on Elasticsearch in my company. And I want whatever skills I have gained over this past years, I would like to transfer it to you guys or would like to teach you about Elasticsearch. As I said, I'm not an expert, but whatever I know, I would love to teach you. I know a lot, and I'm sure I can contribute a lot to you. So let me share my slides. First of all, what we are about to learn in this tutorial. Well, in this tutorial, I would be teaching you, we'll be talking about introduction, learning basics of queries. We'll be learning match phrase queries, match query, query string, nested boolean queries, filter queries, pagination queries, geo queries, aggregation, mappings, and much more. A little bit about myself. I have an excellent experience in building scalable and high performance software applications, combining distinctive skill sets in IoT, machine learning, and full stack web development with Python. Well, about my education, I have completed my bachelor's in electronics, double master's in electrical and computer. The best way to reach out to me would be through an email, and let's get started with the series. So the first step in this video tutorial series would be I would like to first of all upload a data. We would be working with the Netflix dataset. So this dataset could be found in the description section below, or you could download it from Kaggle. So let me share my screen and let's do the first part. I'm right now on the Kibana local host, as you can see, 5601. I would basically click on upload a CSV file here. The screen is loading, so let's wait. All right, simply drag and drop your CSV file. I'm gonna use this Netflix dataset. So it's now analyzing. Usually we write a scripts to do all of these jobs, but let's just, for understanding purposes, let's call this index learn, and let's call the import function on that. This should create an index called as learn, or in simple language, you can say a database name called as learn. Let's wait for it to complete. So it's right now indexing all the documents. By the way, meanwhile that is being done, I'm hoping to do the following things, because let me just show you Elastic. So this is the library, an open source library I have published. I'm the author here. I wrote a library to generate complex Elasticsearch queries. It's officially published on PyPy. We would be using this library a lot to generate about the queries, because this tutorial is about writing queries, right? So now let's go back to the Kibana. So now I'm gonna show you how to write your first very basic queries, okay? So I'm on the Kibana. On the tab, click on the DevTools. So the first command you want to enter is basically get_cat, and I would zoom in as much as I can so that you do not have any problem in seeing what I'm typing here. So get_cat_indices, click on the triangle button right here, and this should basically tell you all the indices you have. And as you can see, I have an index called as learn. Good job. So you have the index. Now let's learn how to query the index. Get the name of the index, and you can say the search. This would basically just search the documents on those index. As you can see on the right hand side, you have these properties in the index on the document: country, show ID, director, release year, rating, description, type, title, duration, cast, and date added. So we have all of these attributes, which is good. Now if you want to get, so as you can see, there are several documents. If you want to get a document, what you could do is you could say get the index name is learn _doc and the document ID. Hit the run button and you should get the document. You could also leverage Postman for this example. You don't have to use what I'm saying is you don't have to use a Kibana dashboard. So I can run all the commands from the Postman as well. As you can see, index_search. I think we have a typo. It's called learn. So let me change that. As you see, I have all the data here, right? And I could copy the same query. Everything what I do on Kibana, you could do it on the Postman as well. Okay, so send. This should give you the data of that particular document. If you want the code for this, let's say you want to write the code in Python, C Sharp, JavaScript, whatever you want, select the language you want, and then here you have the code for that as well. Any language, Node.js, how to do this in Node, Axios, so whatever you want, everything is there. Okay, so that's that. Now, once you know how to do this, now we would like to move to writing our first queries. Please install this following library, which is developed by me, pip install elasticsearch query generator. The links would be there in the description, so check that out. Let's understand the very first step in the writing queries. So don't worry about these all codes. So the first thing you have to do is, as you can see in the documentation or the example, from elasticsearch query generator dot query generator, import elasticsearch query. So you have to import the class. Once you import the class, let's get started with the action. So I created an instance and I gave it a size of 100. Size means that how many documents I want to return, right? I'm saying that when I search, I want 10 documents from the Elasticsearch. Bucket name, you could leave it to default or whatever name you want to give. I would cover the bucket names later when we are doing aggregation. So whenever you create an instance of a class, you can access the base query object. So as you can see, I'm accessing the base query, running that, and this gives me the query. Now I would be explaining you this in a little bit detail. So now what I can do is I can dump the query here. I can say learn underscore search and I can provide the query. Let's just run this and see if it works. Yes, sure enough, it does work. So there are following fields in this JSON documents. Let's understand these one by one. First of all, we have source. Source stands for what fields do you want Elasticsearch to return. As you can see, it's returning a lot of fields. Let's see, you just want title, right? You don't want other fields. Well, you could insert that in the source attribute. And after that, you could run this, and sure enough, all the documents would be filtered and you would only have the title variable there. So that is easy, right? Now the next thing is size. Size is basically how many documents you want to return when you search something. Right now, I'm saying that, hey, please return 10 documents when I search. The maximum cap is about 10,000. If you want to get more than 10,000, you have to do pagination, which would be covering in much details late in the upcoming sessions. Min score is basically, as you can see, whenever you write any queries, Elasticsearch gives a score by default. So let's understand that a little bit. So here you can see these are scores 1. So there are scores. So what we are saying is, hey, filter out the document that has score less than 0.5. I don't need all of that. So just filtering out. Now this is the main chunk of the queries. You have query, bool, must, filter, should, must not. This is extremely important for us to understand this. So before we move that, let me tell you about must. Must stands for AND operator. Filter stands for filter commands. Should stands for OR operator. Must not stands for not operator. That means if you want to write a query like, hey, find me A and B or C. So you would put that A and B query in the must section. The OR operator would be in the should section. And then if you want to filter out something, put that in the filter section. If that should not have any things, you could put that in the must not section. Now the basic, very basic types of query in Elasticsearch are match and match phrase. These are the two most popular queries that Elasticsearch have. Let's understand what's the difference between these two queries. Not everyone understands this, so that's the reason I would like to show you a small demo. I have this 3 document which says I love elk, it's great. I love Elasticsearch, elk, Elasticsearch. I have some terms in that. Okay. Now what I'm showing you is basically let's experiment with the search. First of all, I would be as I said, we are doing the match. So let's search for the word elk, and the field means what field you want to search. So I have a field called text. I want to search on that. So now if you see, all the 3 documents are being returned. So if I add the word search, let's try and see what happens. Is it going to return all the 3 documents? Yes, still 3 documents are returning. That means what happens behind the scene, Elasticsearch, whenever you write a match query, it search for the terms elk and the word search. So then based on the number of terms present in the document, it's going to give you the result. But hey, I don't want that. If I just want to do an exact match, for example, if I just wanted to search elastic something like search, well, in that case, you would use something called as a match phrase. Match phrase. And when you say match phrase, you are exactly matching the phrase. So L can search, as you can see, is only there in the one document. That's why only one document was being returned. Wow, that's amazing. This is the very basic concept. We need to understand this very clearly in order for us to write complicated queries. So now, with that being said, what you could do, let's go to the scaffold generator we had. This is the scaffold. Let's say I'm looking for, first of all, in order, before even moving that, I would say learn, and I would say search. So I would search all the documents. Now, tell me one thing. I would like to search for a variable call. I would basically, I want to write a query where it is where the word blazing, or where the word, let's see, in the title. So what you want to do is you want to search for the word blazing or the killer. So okay, so I want to write a query. So as I said, I want to search for the word, right? So I would use match or match phrase. Think about it. I would use the word match. So in the must section, I'm gonna add a word match, and here it says field. I would select the field to be title, and I'm looking for a word killer in that. Okay, so whichever document has the word killer. Now I'm also, instead of that, let me take a good example which is a long title. Let's say I'm looking for the word Nazi. So if I do that, so as you can see, there are four documents has the word Nazi. So now if you want to say, give me the document that has the word Nazi and camps. So what you could do is you could again copy that. So this implies that you're doing an AND operator when you add more queries here. So now I'm saying that, hey, in the, as I said, must section, when you enter something in the must section, that means it's an AND operator. So now if you search, only one document was returned. That means you told Elasticsearch, hey, please look for a word Nazi please look for a word Nazi and camps. Does that make sense? Now the same thing, if I put that in the OR operator, now see, you would be, what happens? So I put that in the OR operator, that is search for the word Nazi or camps. So when I run the query, I got much more documents. I got 4 documents that has the word Nazi and camps. So you see, that's an OR operation. So now let's say I got all these documents in the OR. Now I want to make sure that the word mega is not included. Well, it's easy. You could include that in the must not section. So I'm saying that, hey, look for the word Nazi or camp, and that, or filter out, and the document should not have the word, let's say mega. I'm assuming it to be work. It should be working. And sure enough, it does work. As you can see, now we have 3 documents here. So we removed the word mega from this. So you see how easily you could form complicated queries. Now let's say you want to filter out all the dates. So as you can see, the score is 15. Here we have a score of 3. Here we have a score of 5. So what you want to do is you could also filter out the documents with the score greater than 4. So in this case, this document would be removed. So now let's try that. And sure enough, it does work, right? So as you can see, so powerful and so easy. It's intuitive, right? If you understand the basic, I think everything should be so easy. So let me go back to the basic again. We have 4 sections: must, filter, should, must not. As I said, must is an AND operator, should is an OR operator, must not is a NOT operator, filter will be filtering out the commands. So that was basically about the match and the match phrase and the boolean. Now level 2 would be, hey, could I write a nested boolean queries? That means what I'm trying to say is you could write a nested boolean query inside this. So even that is possible. I'll take a look. I'll show you how to do that. So give me 1 second. But this should be very much clear how to write the basics. So first of all, we learned the command cat indices. We learned how to search, right? And then we basically learned the basics of Elasticsearch, that is source, size, min score, query, bool, must, filter, should, must not. So these are the basic. Now let's see about the nested boolean operators. So let's take a look at the nested boolean operations. So remember how I said, for example, now before even adding this, let me actually remove this and want to show you something nice. So this is what we had before, right? So now what I'm saying is, with this operation, what you could do is you could only achieve following things in this. If you want to go beyond this complex queries, what you can do, for example, must represent an AND operator. Then, as I said, should represent an OR operator. Then must not represents a NOT operator. Okay, let me This is very, very important, guys. If you understand this, and the entire Elasticsearch becomes a piece of cake for you. Okay, and then the filter would basically filter out. Okay, so with that being said, if you want to do something like this, tell me about if you can do that or not. For example, you said whenever you enter something in the not, it's basically don't include that word, right? What if I include too many? I want to say like, hey, search for the document this and this. Then I want to make sure that, the document should not have this word or that word. For example, I know it's a little tricky, but just try to understand. So I'm saying that, hey, the title should include the word norm or the king, or, so let's do a very easy. So let's say the title should include norm or king, right? So it's an or operator. We should just put in the or, and then you want to filter out, make sure that it should not contain the word X or Y. So if you want to achieve some kind of this, if you want to do something like this, well, you have to use a nested boolean queries. What do you mean by that? Saumil, basically, you see, I have a bool again inside a must not section. First of all, let me try to implement this. The title contains norm or that. That's easy, right? So we come here. Okay, we have a match query. We use the word match. We call title here, and we say, hey, can you look for the word king? Then once you do that, I also want to say this, look for the word this. I would indent all the query, so don't worry. I know it's a little it's hard to see. I'm just zooming in because I want you to see this carefully and understand the concept, because once you understand this, I think everything is a piece of cake. Okay, so with that being said, if I just run this code right here, oops, seems like we have an issue here. Let's remove the must not for now. Okay, so we have all of these documents, right? So let's see how many matches we have. So we have 32 matches, okay? And now I just want to see title and see how I'm teaching you now. Okay, so I'm gonna see the word title here and run this. Okay, so these are the, dinosaur king, because it has the word king in it. We have this king jack, or, you know what I mean, right? So all of these documents, there are 30 documents. Now, what I'm saying is, whenever you give me the result, make sure this document does not have this word or that word. So I want to do a not operator. So what I'm doing is, so I'll collapse the should operator. Now remember, whenever you enter something in the must not, that means it should not contain that word, right? Now what I'm saying is, I'm gonna actually copy a snippet. So in the must not, again, you want to say, you want to do an or operator, right? So I want to remove all of that, and let me know if this makes sense. Actually, let me do a little JSON formatter, because it kind of get a little ugly here. Let's go to Elasticsearch, paste the formatted query. I would collapse the, now you see what I did is, in the must not, I said bool and then the should. So I'm saying that make sure that the document does not have the word, let's say picking. So now let's run this query and see if it works. And sure enough, it does work. So now we do not have the word picking into that, because we said this. Now let's say we want to do an or operator on a not. So what I mean by that, so it should not have the word picking, or it should not have the word jacking. Okay, if you understand this, guys, you're like master. I mean, trust me. So now if we say the word jack, so see what happens now. We have less documents now. Okay, so as you can see, before this, okay, we had 30 matches, I guess. 31 matches, right? Now I'm entering one more rule here, right? So I'm saying that, so try to read this with me in English. Okay, let me remove this operator so it's more a little easy. Okay, so what are we doing, guys? We are saying that, hey, give me all the document that has the word king or Nazi, and make sure that these documents should not have the word picking or jack. So if you run the query, sure enough, we have more filter data. We have 29. We filtered out few more documents. So as you can see, there is no word called jack here. Similarly, no word called jack. no word jack or peaking. As you can see, it seems like working fine, right? So you see how amazingly powerful Elasticsearch is. So you could write nested boolean inside a boolean. You could achieve whatever you want. So what I did essentially is here this. So let me write it in English, where title is, so I wrote this query. Title is A or B. Title is A or B and not of A, this is C or D. This is exactly what we did. So you see, this is a very complex. Okay, let me just switch my screen again. So if you did understand this, I mean, this is not easy, right? We made a very complicated nested Boolean queries, right? So you see how easily you could implement any sort of logic, A or B or C and this or that. So it's just about if you understand the basic, it's just piece of cake after that. All right, that's great, Samuel. This looks amazing. I mean, that's pretty much great. Samuel, do you know how I can do scrolling by chance? Yeah, sure. Let me show you how to do that. So if you provide the word question mark and scroll equal to, and if I say 1M, and if you search, and sure enough, now you can see if I make the document size to 2. And now you can see I have 2 documents and have a scroll ID. So whenever I want to go to the next document, so I want to get the next result for this same query. So if I'm not wrong and if I know the things correctly, we could recollect it again. So let me do scroll. We say Kibana Elasticsearch. Just want to make sure that I don't forget, I don't give you wrong information. That's why I just want to verify the things. I think I know it's post, basically it's a post API. So I just got to verify that quickly. I guess this is the link. Yeah, so yeah, that's the one. So we gotta copy that. And remember, whenever you go for the next document, you never specify the index name, okay? So now in this, I'm gonna grab this document, the scroll ID here that I got. Okay, and we go. And we get the next result. You see how amazing it is, right? So easy, right? And guys, you could use this in Postman, right? You say, Samuel, how show me, how do I do that? Well, no worries, relax. First of all, we just basically have to do this, I guess this, and where you have this JSON body, right? So that JSON would be supplied as a body. Go to the raw and make sure this is JSON. Dump that here and send. And here you can see we have the result. So you don't need Kibana, you can use Postman. I mean, if you know what you're doing, right? So hopefully that should make sense. Now I have something to say here. Guys, I want to say, like, do not use this scroll method, because I'm telling you from my experience that I've been working in the companies. So let me show you why. Instead of doing that, I would leave all the links, so don't worry about that. There is a better way to do pagination. I think I did upload on my blog 4 ways to do pagination. The method 3 works the best. This is the best method to do pagination. So we use search after queries, right? You could come here and read a little bit. I have a video as well. And the reason I'm saying is because what happens is when you do this pagination, Elasticsearch would store their things in the cache, and there would be like the problem with the expiration. Think about if 20 people are doing different searches, all the results are being accumulated on the cache. I know this is gonna be only active for 1 minute, but if you see what I'm saying, it's not the best thing. So I'm saying instead of this, use a search after query. This is my recommendation based on my experience. I'm saying use search after for pagination. The blog is there. Kindly go ahead and read how I did. And if you have questions there, I would be more than happy to guide you out. Oh, this is how you do it. So that's about the search after query. Okay, now comes the very interesting part. Okay, so we did all of these queries. We understood this amazing complicated Boolean queries and all. Give me one sec. My actually throat. Yeah, so you did all of this. Congratulations. First of all, good job. Always. Now what you want to do is you want to learn different sort of queries. So let's head over to here, and I'm actually trying to gonna walk you through all of the queries. So this library would, what I just said, it generates all the queries for you. You don't have to write all this manually. So for example, if you want to write a match query, takes a field name. So let's say the field was title, right? And the value, I think I'm forgetting a quote here. The value was, let's say looking for the word king, and you want to put this in the should operator. Again, if you want to write this one, I'm just showing you a better ways to do this. That's why I'm saying, let's follow the best way. I developed this library so people could use it. I mean, you don't want to write all of these by hand, all these queries. Good luck with that. I mean, if you want to do that. But yeah, so let me try to run this and show you. Same thing, we'll get the queries. All we are doing is programmatic. So check this out. Should operate. So we have king or norm in the boolean section. So yeah, this library is amazing. I developed it. You just have to supply operation. Operation is must not, should. So you could do all of that fancy things. So whatever complicated queries you want, this is the way you do it. Okay. All right. That was about match and match phrase. So match phrase would basically match the exact phrase, right? I taught you about that, so hopefully you know about match and match phrase. Okay. Now, another type of query that I would like you to introduce is, all right. So we are about to learn about the aggregation now. So yeah, aggregation could be complicated. These queries are like so nested queries and all of that. But hey, don't worry, I got you, man. We have this library, right? As I said, it's officially published on the PyPy, I guess. Oh yeah, this one. So it's there. Everything is there. So, okay, so download that, have fun, play with it. Okay. Now let's talk about the aggregation. Excuse me. So we are about to do aggregation. So what we will do is basically we have done all of these geo queries. That's fine. So in order to add aggregation, you would use the word helper.add_aggregation. You would give the name of the aggregation. In this case, let's see what fields we have here. Get, learn, search. Okay, so we'll do that, and I'll show you an aggregation now. So let's try to do an aggregation maybe on the duration. Okay, so what we'll do is basically we'll call this duration. I'll just put the D as capital to the name. That's the bucket name that I'm going to provide. Now here, what I'm going to do is I'm going to set duration and leave everything to default. So let's run the query and see what we get. Seems like, oh yeah, I know why. So, wait, I'm not on the right, am I on the right stuff? Oh yeah, I'm not printing it, that's why. Yeah, so let's print that one, and let's see the aggregation in action. So we get this query, copy that, dump that here. Okay, so we have this aggregation. We are saying that, hey, find the word norm and then do an aggregation on the field. What's the field we have? Yeah, duration. So we just run this. Let's just do, yeah, that's the aggregation. So here you can see for that the word norm, there are these many documents. So let me actually remove this. It might be a better to show you actually what it does. So I would do the size as 0. Search that, and yeah, now you can see. So the duration 90 minutes, there are 111 documents. Similarly with 91 minutes, there are 104 documents, and so on, right? So that's about aggregations. If you want to do aggregation on multiple, what do you call that? Multiple fields. Let's say I did for the type, right? So I also want to do for the cast. Hey, it's very easy, man. You just gotta add one more method. Just call this one. Let's call this as a cast. I want to make that C capital. Let's give it a field name that means the field on which you want to do aggregation. And hey, that's pretty much it, man. Let's remove the match query, the wildcard query. We don't need that. So just want to do an aggregation. Okay, grab the query, put that here and here. So once we do that, we search the documents. Oops. It seems like 1 sec. So maybe I'll do it on Rating, let's do a rating, maybe that's much. Oh, my JSON is also a little bit backed. Okay, so we do our aggregation on rating. You see this library generated this all for me. Okay, so you don't have to write all these complicated queries. That's all. I'm just showing you how to like make everything work together. So let's remove the hits, and this is the aggregation. So here you can see that's the aggregation, and for ratings it seems like it did not do the aggregation. Was it ratings? Okay, ratings field rate. So as far it seems like the mapping of these field, the rating field was not appropriate. That's why I guess it's not able to do an aggregation. Let me just do 0 here and try that out. Yeah, it seems like I was not able to do the aggregation on the rating. As you can see, it clearly shows an error there. It's fine. It's not a big deal. But what I wanted to show you is, how to do aggregation, how to add multiple aggregation. So the library actually does that job for you. Like as I showed you, you just gotta call dot add aggregation, and once you're done, you call the method complete. All of these examples are already given on the documentation, right? So that's the aggregation part. Okay, so we'll remove that one. Okay, so aggregation. Now what you could do is you could add queries here, like whenever you wanna, for example, I don't have much of massive data, but let's say you wanna say you wanna do an aggregation. So hear me out. Let's say let's say there is a movie called I don't know. Let's see, I'm thinking of a good example. Let's say you want to do an aggregation on job titles, right? So you want to do an aggregation on job titles. What would you do? Let's say you want to filter out. Let's say someone said, oh, do an aggregation for software engineer. So you want to do an aggregation on other fields and see, okay, how many, what's like a document count. It would give you like a document count. So for your stuff. So that's about aggregation. I mean, that's the easiest I can explain you about aggregation. So okay, so that's that. Coming to the geo queries. So one thing that Elasticsearch does is basically, if you put this document here, actually I want to delete the document first, making sure it is not there, and then we'll create it. So if you see, I'm adding this document. Okay, so what happens is if you do not specify the mapping, Elasticsearch would create a mapping. For example, there's a field called geo, right? And you can see the type is text. So I cannot do radius search and all of that functionality. In order for me to do all of that, I have to define a custom mapping. So let's delete the index first, ABC. I'm gonna delete that. Okay, that's done. Now before even like sending the document, you have to define a mapping. Mapping would be, let's see if I have the mapping first. I think I had one. I mean, or I can write one. That's not a big deal. I think I had one, but it's fine. We can always get the mappings from Google. It would be a good habit for you as well to how to do that. So okay, we want that, right? So Elasticsearch geo mapping. Okay, you Google up the first one, go to the official documentation. Usually the documentation is the best place where you could get things. Okay, go to the official documentation always. Well, okay, so what I'm saying is now we will do this and we'll put a mapping here called what you're doing is mapping means the data type. We are saying that, hey, this field called geo would be a type of geo point. We are customly saying to Elasticsearch, hey, please, you do not do your stuff. I'm telling you what to do. So we said that, hey, give it a mapping called a geo point. So we defined that, right? Excuse me. So once we do that, you can see we should say acknowledgement true. And then when I upload the document, the same document, and then I go to the mappings of that index, if I search for the word geo, and you can see it's a geo point right now. Once that is done, what it allows me to do is it allows me to use geo queries. For example, I want to search for the word New York. As you can see, the word New York is there. And then I want to filter out all the people which are in 2000 kilometers. Right now, it's just a one document, so it's just going to show up that one. But what I'm trying to say is you could add these rules here. Like you could say, I want to do this, and then from that result, filter out everyone who's between like 200 kilometers or 200 500 miles or something like that. So that would be regarding the geo queries in short. Okay, so that should explain, that is pretty self-explanatory. Other thing that I would like to ask is you could also do an aggregation on the geo queries. So what I mean by that is, let me show you. So I think I would have to disable all of these one. I'm not sure. Let's see if it works. So geo aggregation basically does aggregation on the geo. It seems like there's an error. Maybe yeah, I think like I think you have to call it complete method. I think this function is not complete yet. I was working on this library. I was adding a new feature, but seems like I never added this code. I have this one. So base query, we return the base query. So I mean, it should work. I don't see why it should not work though. Oh, it has to take all the fields and stuff. What am I doing? I'm just going to give a one shot and let's see if it works. Okay. So geo aggregation, field name, lat, I give a long aggregation, my distance. What is this? Type error, non-type object is not supported for assignment from 100. Does it take anything else? Let me just make sure. Aggregation. Well, I'll fix that part, but you could probably do aggregation on the geo points as well. So that's that. Now, what else I want to cover is, let me think about this. So I guess I've covered most of the points on the queries, and now I would like to cover a few more additional aspects of queries, such as I would like to cover, let me see. So I would like to cover about aliases in Elasticsearch. I would like to teach you about aliases. Once we do the aliases, then I would like to show you a little bit about what was that? The autocomplete queries that I have been working on, just some fun stuff that I want to show you, just about the queries. So everything about the queries, then how to update the document, or how to add a field in that, something like that. So let me show you a little bit about that now. About Elasticsearch aliases in detail. So I would be talking about this aliases, what aliases are in Elasticsearch, and why is it so powerful that you should definitely learn about aliases if you are working with Elasticsearch. I'll be talking about, first of all, about simple aliases. Then I'll be talking about filtered aliases and a little bit about routing and writing aliases. So let's get started with this video to make you guys understand what aliases are in Elasticsearch. So let's get started. So let me minimize my video for a while. Okay. So aliases, right? Now, for example, like my alias or my nickname is scientist. My original name is Saumil, right? People know by Saumil, but people also know me by a name called as scientist, or that's called as an alias, or you gave me a nickname. Some people also gave me some other nickname. So these are aliases, different ways of calling me, right? So now what I'm saying is, so let's create an index first of all. I want to create an index called as my first index. I usually like to explain with examples. So, so we created an index. Okay, perfect. Let's insert some document there. I'm going to insert a document called Suhas. That's my mom's name. Then we're going to insert something called Saumil. Oops, I messed up. Yeah, I messed up. So now let's insert one more document called Saumil Shah. Let's do Nitin Shah. And let's just do OK Shah. Okay, so I have these 4 documents here. Hopefully that should make sense. It's nothing complicated here. So I want to just show you all the documents that I have in this by saying search. So let me show you. Oops, one sec. I have 2 double score. Okay, simple. Nitin Shah, Saumil Shah, OK Shah, Suhas. So these are all the documents I have. Now, what I'm doing is basically I'm creating an alias for this index, saying that alias 1. I'm giving it a name. So what happens is basically now I can query the data with this alias. Okay, I'll show you what it means. Don't worry, I'm there. Let me explain you. So created. Okay. So of course you can search this index by its original name. That is my first index. But now once you did this you have an alias, you can also do my alias 1 underscore search. It returns the same set of documents. That's amazing. Now you would say, oh, that's amazing. But when will I use this? Well, think about a situation where you have a read-only database in Elasticsearch prod environment, and you wanna so you have some data, right? And after several months, you have to ingest a new data. So what you would do is basically you would create a new index and you would push all the data there, and then you would basically create an alias of the original index, and then once the alias is created, you would delete the old index. So for database migrations and for when a new data comes in, so all of this, for all of these stuff, you would use aliases. So very, very powerful. Now let me show you the power of filter aliases in this example. So if you want to remove aliases, of course, you can say remove, I guess. Yeah, so you can say remove. All the code is there, so don't worry about the code, guys. Focus on learning for now. So let's remove the alias. Okay, so remember in this where is that index? I get my first index. Okay, so remember how in this document we had sha as a sha everywhere, and in one document we did not have that sha. So if I want to show you oh, not this one, let me just do a normal search here, this one. So remember, guys, we have Nitin Shah, we have OK Shah, we have Saumil Shah, and then we have Suhas, that's my mom's name. So this document does not have Shah. So if you want to create an alias which only includes the last name like Shah, so what you could do is that you can use the power of filtered alias. So look at this. So I'm creating an index. I'm basically creating an alias as alias2, and I'm saying that, hey, only make sure to include only Shah in it. So when I post this alias, right, makes sense. Now when I search it, if you see, Suhas is not there because this is a filtered alias already. When creating an alias, we already entered a filter command. You would not include anything that does not have Shah. Isn't that amazing? That's pretty powerful, right? Like for all the BI tools and all, you can create multiple aliases like this. Okay, that makes sense. Okay, that's pretty good. Now you say, Samuel, where did you learn all of this? Well, I usually read a lot of Stack Overflow. I read this guy. I would put the links in the description. He explained this there. So he also gave a very nice example. Say you have log indexes. So let's say you have a 2018-02 logs, which has all the logs for the year 2018 February, and you have another index called 2018-03 logs, which has all the logs for the month January, February, March. Okay, so now if you want to query both the indexes at the same time, you would create an alias called current log, which is pointing to both of these, and then you can just query the data. Wow, that's amazing. It's pretty amazing. Okay, so that's that. If you really want to learn more in depth about aliases, you can come to the official website, and they have a pretty decent amount of documentation here. They talk more. I mean, there is a lot more here. They talk about routing and all. So you can of course come here and check about routing. You can read a little bit here. I mean, I tried my best to explain the basics and the fundamentals. So there is, like as I said. So only thing that I've not covered, I guess, is the write index and the routing. And I guess it's pretty self-explanatory if you read. Routing is possible to associate routing values to new alias. The feature can be used together with filtering aliases in order to avoid unnecessary shard operation. That makes sense. The following commands creates a new alias1 that points to index test. After the alias1 is created, all the operation with this alias are automatically modified to use the value 1 routing. So it's self-explanatory. So he explains. So basically, this is used to create an alias1, which basically points to the index test. And then, as the documentation clearly says, it's usually used to avoid like the shards operation, unnecessary shards operation. And you can automatically use value 1 for routing, and then you can use value 2 for routing. I haven't explored much about routing in detail, but yeah, this is what aliases are. Basically, learn about Elasticsearch array mapping and how to search within those array. So we're going to learn about some queries in that. So we have a question from Keval Jain. He posted 1 day ago, and we are kind of addressing this issue. He has a array in which he has those nested documents, and the problem is he basically want to say like whether the main vendor is n and the priority, let's say, is 1. So I mean, the thing is, this is considered as a one document, but he wants to only get this document in the result because that's the match, right? So let's kind of learn about a little bit about array mapping and writing queries about that. So let's get started. I have a very nice demo here for you guys. So first of all, sorry for the background though, I'm in India. So yeah, so put my index doc1. Okay, so I'm gonna put this. Okay, so this should create the index. So here you can see the index is created. Let's have a look at the mapping that Elasticsearch did generate for us by default. So I'm gonna show you the mapping. So you can see the user is a user.
Then we have property, of course, first, which is text, and then we have a field like a keyword, so we can do that, all of that. So that's that, right? Now, if you want to do something like where the user dot first name is John and the user dot last name is Smith, it should return only this document. I don't want to return the complete document, but the problem is this is entire one document. So you are trying to index a document inside or something like that. So there are two things. You can use like a script query, of course, but that's slow, not pretty efficient. What I would do is this. Let's understand what Elasticsearch does. So let me copy this above so I can explain you first of all. So when you do array, right? So Elasticsearch behind the scenes break down into this. So user dot first. So all the first name would be an array, last name would be an array as well. That's how Elasticsearch does, okay? And I'm not talking this from my own stuff. This is there on the official website of Elasticsearch from where I am talking about, okay? So that's that, okay? So what we want to do is if you do something like this, it's not going to work. So of course, we have bool must means it's an and where the user dot first name is Alice and this last name is something like whatever, like let's say last name is what was that, Alice White. So you want to do that, right? But it should only return that particular JSON. But the thing is, this is just one record. It's a complete record. You are trying to do search inside that record. So it's interesting. So if you try to run this query, what will happen is I'll show you. It's gonna match, right? Because those two words are there in the document, and the thing is, I don't wanna get this one. How do I do that? Of course, you can write code to filter out that, but is there a way I can do that at the query time? Yes, you can, and let me show you that one. So that's the part two now. So now how can you do that kind of stuff, okay, with arrays and mapping, basically nested documents or nested array documents. So first of all, very important, you have to define a mapping called nested. So user is a nested, right? You have to tell Elasticsearch, hey, that's a field called as nested. You have to explicitly say Elasticsearch. You have gotta define that. But if you already have an index and if you don't have that mapping, you cannot do that because you gotta delete the index or I mean, yeah, you gotta you got you gotta do this when you create an index, right? So you do that, okay? Acknowledge true. Now we'll do the same documents, okay? Same document right there. Now look at the query. So I'm saying that I want to look for a document like Alice and White, okay? So, but see the catch here. This query is wrapped inside a nested one, okay? So when you wrap it inside a nested, okay, path as user, that means you're telling it to look inside this one right here. Then you're saying query. Inside that, you're saying a query, bool and must. So you must have this and this inside these documents. And inner hits, of course, is for the inner hits. And check it out. So if you, oops, I fucked up somewhere. Nested object under path user is not nested type. Hold on. I screwed up something. It's fine. So let's do that. Okay, now it's done. Let's put the document right there. Perfect. Search and there you go. Now you gotta understand here how everything works. Okay, so first of all you have hits. Okay, in that hits you would have the outer document that is being matched. Okay, so for example, if you see carefully, we have a source, right? So let's collapse the inner hit right here. Sorry for the background noise. So basically we have where was I? Yeah, sorry. So we have this hits, okay, and in that hits we have one more hits, and in that we would have two things: source and inner hits. So the source would be the outer hits, and the inner hits would be what you would want to look for. So if you see, you want to look in the field. You want to look in the field basically called source, right? And here in the source, if you see, these documents were matched. So Alice and White, right? But in the outer document, if you see that, so if you collapse the inner hits and I open the source, that's the main source, right? Where both the documents are there. And if you want to filter out stuff by inner documents, you would go to the inner hits, and inside inner hits, you would go to, again, remember that this is a flow, okay? Inside inner hits, you want to go inside hits, and then source, okay? So hopefully that makes sense, right? So now you would say, Somil, what if I want to get like Alice or first name is John? Well, it's simple, piece of cake, guys. Let me show you. What was that? Was it should? Yeah, should. Okay. User dot last. Actually, let's say first is white, and I want to remove the. I want to put it in the or section. Uh, let's say user dot first is what was that name? John, Alice. Let's see what do we get. Okay, so run that. Oops, I think I have a syntax error. I always do this. I mean, always. It's kind of hard to find the typos usually. Especially I don't have my specs, so it's even more harder to look. Okay, we'll fix it. No worries. Let's try that one. User is white. Bull should match user dot first. Is there a first name? Oh yeah, of course there is no white. So it should be Alice. Try out that one. I'm not interested in the outer hits. I'm interested more in the inner hits. So so of course I told you the format. Remember? So hits. So that's the outer hits. One sec. One sec. I should have worn my specs. Let's see this one. So that's the outer hits. Okay, yeah, inner hits. So now if you see, White is there, right? Their first name and last name, right? So Alice and White. So that's that. But interesting thing, if you just want the first name in that, so say you said Sawmill. I mean, I that's correct. It's working fine, but I just need the first name. I don't want the last name. You want to still filter it out. Okay, okay. I don't know if this is gonna work. Usually it works in the nested queries. You can use a source attribute, like that one, and user dot first. Let's try out that one. And it seems like I cannot do that for some reason. Malform no start object after query name. I think I cannot do it here, but let me see. Let me see the query 1 second. So usually it's above. Oh yeah, it's above the query. Of course, it's not gonna work here. I should have done somewhere here. Should work? Still does not work. That's fine. We can, of course, right in the code we can filter out that stuff. It's not a problem. That's interesting. I guess I gotta even go in the outer level. So maybe that one. But the thing is, this is gonna filter out the outer stuff. So if you see, hits. Let's see the inner hits. Yeah, we still have that. So that's but yeah, this filter out the outer hits. Yeah, that's the thing. So yeah, for outer hits it's fine, but if you wanna filter out the inner hits, I mean technically it should work. Let me see. So I did it. It should work if I put it here, but it seems like for some reason it did not like that. Maybe that way. Nah, it did not work. It does not like that for some reason. Maybe here. Nah, it's not gonna work. I'm pretty sure. Yeah, it's fine. You can write a JavaScript code on the client side or on the server side. It should be easy, right? That should be pretty simple, right? So that's that. What else? So of course you can use should, must section, must not section, and all of that. So to filter out the documents, and if you want to filter out, if you want to, like the name is Alice, and you want to filter out everything by, let's say, last name is like whatever, like regular expression, you can do that, right? You can keep adding as many queries you want in the boolean sections. So hopefully that should be it. This should give you a very good start on elasticsearch mapping and nested JSON documents, filtering out nested JSON documents. I'll do is I'll put this links in the description. This is where I learned from. So they have an example here, right? They did show how to use these queries. Yeah, so that's that. The nested fields, you got to define a mapping. Of course, then you put the document. and of course you can put it in the bool section, and it should be in the type nested, right? You can do that. Of course they have more, you can do highlighting as well. They have a highlight fields, so that's that. So yeah,
I'm going to be talking about how to update records on Elasticsearch. So let's get started. So I'm going to be opening my DevTools here to show you for example. So I have a Netflix dataset in which I'm going to be explaining you this. Okay, so I'm just going to do a random search query here. I think I'm going to provide the JSON body. Okay, so I'm gonna be playing with this one, this particular record. So I'm gonna copy that on a notepad. Okay, that's the record. Let's play with it, guys. So first of all, what I'm gonna teach you is basically how to update a key value. Let's say here in this data, let me actually grab the ID. Oh, okay, that's much better. Not the dev tool. I don't know why did that open up. Okay, so let me actually get the record of that guy. Okay, so for get Netflix _ doc and okay, run it. Okay, so you have the data here, right? So here you can see about that guy. Now what I'll do is basically I'll add basically a new let's say name called as Somil Shah here. So let's try that. I have a template here. So the template says you first say the index name. Then you have to give it the ID of that person. They use a script tag. Then here in the key, you would say whatever you want to say. So name. Okay, now if I run this, all the snippets are there in the description, so you should not worry about these snippets. Okay, so updated. So now if I do doc, in this to get, remove the JSON here. Okay, now if I try to run that, now that particular record, we have a name attribute. Perfect. Okay guys, how do I delete that? Okay, so I have again a snippet for that as well. So easy, Netflix, update, give it the ID of that person, or the record, I would say. CTS remove and the key. Wanna remove the key called as name. Updated, right? Perfect. JSON body. Okay, so you see has been removed, right? Now let me also talk about updating fields. For example, let's say title, transformer, minister. So let's do that, man. Alternatively, you can also do this way if you want to update things. Are we rolling? Let me see. Okay, perfect. So ID, title, yep, that should be fine. Updated. Let's get the record. Title Somil Shah. One thing, if you update things, you cannot revert it back, okay? Because you already made the changes, so you have to be very, very careful for that. So yeah, I hope you have enjoyed this quick tutorials on Elk Stack for updating a key value pair in a document or deleting them. I'll do is basically I'll put the snippets that we have done in this tutorial in the description of the video. Okay, all of these. Talking about Elasticsearch analyzers, what analyzers are and how you can leverage the use of analyzers in Elasticsearch. So let's get started with the video tutorial series. I have some I have some very good examples which will make things easy for you to understand. So let us see what are the analyzers, types of analyzer. Elasticsearch offers following types of analyzer: standard analyzer, simple analyzer, whitespace analyzer, stop analyzer, keyword analyzer, pattern analyzer, language analyzer, and fingerprint analyzer. Now, the very first question anybody would ask me who don't know anything about analyzer is basically, what is basically an analyzer, right? So to answer that, let me show you some of the documentation of Elasticsearch, and then we'll understand these analyzer in detail by looking at the examples. So I'm on the official website of Elasticsearch. Elasticsearch, it says Elasticsearch ships with a wide variety of built-in analyzers, which can be used in any index without further configuration. So if you see standard analyzer, the standard analyzer divides the text into terms of word boundaries as defined by Unicode. So let's read stop analyzer. The stop analyzer is like a simple analyzer but supports removal of stop words. Words like the, full stop. I will explain you all of these with a very nice example. But let me just show you what happened, okay? So for example, I have a wonderful example here. So which shows a different analyzer. For example, I wrote a sentence here. Hello, my name is Saumil Shah. I am a full stack software developer. .111. Okay. So when we, by default, if we don't specify anything, it uses standard analyzer. So what I mean by that entire text is broken down into tokens of words. Hello, my. So you can see this array. So whenever you say like, hey, find me the word hello in this, so it's gonna quickly grab the word hello and it's gonna give it to you. That's a standard analyzer. Then we have a simple analyzer. So what happens in the simple analyzer is this: if you see the number 1111, got rid of that, right? So the numbers got rid away. So if you wanna have some application where you wanna get rid of the numbers or something like that, you can use simple analyzers. So if you wanna read more, you can always come to the website. The simple analyzer divides the text into terms whenever it encounters a character which is not a letter. It's a lowercase all terms. Makes sense, okay? Then comes to the white space. So white space analyzer splits the string at a white space, which makes sense, right? So the length of the array is still 12. Here you can see. So if you observe the word developer.111, since there was no white space, this is how it came at the index time. It will be this word. You see, so it's very, very important to just understand how analyzer work, because based on the type of analyzer you provide, you're gonna get relevant results. For example, the stop, if you see the word dot, the full stop was taken out, the 111 was taken out. You see, all the stop words were taken out. Similarly, keyword means this entire text would be treated as one keyword. Similarly, we have a pattern analyzer and fingerprint. So that basically gives us a very nice idea of analyzer. Now the question might be, okay, how the hell do I use it? I have very, very nice documentation or I would say an example for you guys. So let's learn that. So I'm gonna create an index with which has a field called as my text. The type is text, okay? So basically just creating a field, okay? So I'm gonna run this one. Actually, before that, I need to delete the index, because already I think I do have the index. So I'm gonna get rid of the old indexes and I'm gonna try to explain you. Oops. Now I'm gonna start with this one. So we created the index, okay? So we have an index. You can verify that with this command. So for example, the name of the index was my test, right? Everything is okay. Now we post one document into it. Hello, my name is Saumil Shah. Okay. Okay. I am. So it's basically a sentence or whatever you want to call. So I'm gonna post that. So we get an acknowledgement, and when we search for all the documents, we should see that sentence here. Now what happens here is at index time, for example, now here is where I need to explain you stuff. So at index time, Elasticsearch convert this into an array. Hello, my name is, because by default it uses a standard analyzer. Remember that? Saumil Shah. Okay. I am. So these are the words, right? Now if I want to search the documents here, I can actually prove it to you that like how it works. So for example, get my test. I'm gonna say search, and if I just provide a very basic query, let's do a match query, and the field name would be, of course, you know that, my text, because we just have one field here. Let's search for the word the. So let's see if we do have a match. So it seems like we did not match anything. Let me do it again. So let's try for the word hello. So you see it did match, right? The hello was there. But what if I try capital? It still matched, right? Perfect, makes sense. So for example, if I try to see for the word hello, like I want to look for hello, anything like that, still shows up. Now let me say something like this, XYZ, XYZ. So this will basically search for the word and XYZ, XYZ. So for example, it should still match the document. So makes sense, right? How Elasticsearch works, like it breaks down these sentence into tokens, so you can do efficient searching. So this will make even more sense. I have much more better example. So let me show you. So I'm gonna delete now. So now let's create an index with a custom analyzer, okay? For example, let me take a better example before that. So for example, if you wanna, let me see. Okay, let's look at this one. This is a very good example which will clear your concepts. So let's say I just run the code, right? For example, if I try, oh yeah, because the index is not created, right? So I need to create an index first. So let me do that. Okay, perfect. Now I'm gonna try that. So check this out, guys. This is important, okay? When I use the test index in which I did not specify an analyzer, right? So the length of the array I have commented here, it is 11. So there are like 11 elements. So you can see the number 2, the number quick, the brown. So as I said, at index time, it basically breaks down into tokens, right? But if you do specify, I just want to show you, like if you do specify an analyzer, for example, let's say you want to remove all the stop words like the, full stop, and all of that. So when you specify an analyzer and then when you try to search for the word the, it's not going to show up because at index time you skipped it. You specified an analyzer, right? Now, a little bit it's making sense. I hope it's making a little bit sense. Okay, so let me show you one thing. So now let us learn basically. So what I'm saying is, we know that Elasticsearch has all these fancy analyzers and stuff like that, okay? But how can we define our own custom analyzer, or how can we actually use it? So let me show you an example. I have a very simple example that I'm trying to explain you. Let me get rid of that one. So okay, so we have a mapping, properties. This is the field name, that is my text, right? Earlier we did that, right? Now we had a type text. So if you see on the first example, we had a type called as text. But now after that, I'm also specifying the analyzer. So I'm saying, hey, analyzer, my analyzer. So the analyzer that I define the analyzer. Now, if you want to define the analyzer, this is how you do it. In the settings, you would say analysis. It's a JSON body. Now, the analysis takes an argument called as analyzer, which is again a JSON. Then it takes the name of the analyzer that you want to give. So in that case, I just said my analyzer. Type as custom because we are, making our own analyzer, right? You can use a built-in analyzer also, like stop analyzer and stuff like that. So let me just explain you, okay? So type as custom, tokenizer as standard. So what tokenization you want to use? So we're just using a standard stuff. Now filter, this is very important. So here is your custom like filter. So I'm saying whenever you put any documents on Elasticsearch, convert that all into a lowercase. So if, for example, if this was a sentence, so this will be interpreted in Elasticsearch as hello. You see, so that's the lowercase analyzer. The English stop words means that we are simply trying to we are defining our own like a filter called as English stop, because there's nothing called as English stop. We need to define that. So if you see below in the filter, I defined English stop, type as stop, and then I said stop words. So for example, I said what are the stop words I want it to understand. So for example, I'm saying whenever you encounter the word the and over, remove that in the index time. So for example, if I said something like, So if I said hello, the tree is great. So for example, if this was my text, this would be interpreted as hello at index time, okay? Hello, tree, and is great. So these are the words for, so the word the would be skipped, okay? So you would also save like memory. So it all depends like what is your application, and then accordingly you would use your analyzer. So I did that. For example, I said the and stuff. So let me actually run this. Okay, so that was created. Now let me show you the difference, okay? The same word, the two quick brown fox jumped over the lazy dogs. If I run that, here, now check this out. The word the should be skipped at index time. So if you see, the word the is not there because in the stop word we defined that it should be skipped. So at index time, if you try to search for that word, it won't be there. Does that make sense how Elasticsearch works? For example, in case of the index test, in which I did not define my analyzer, here you would see the word the. For example, let me show you. Check this out. See, you see how easy it is. It's pretty easy once you start understanding stuff. I mean, you would really love learning stuff. So for example, as I said, so my test, now I'm gonna look for the query word the in that. Now I defined my analyzer in which I said explicitly the word should be not considered at index time. So if I search, no document found. So you see how it's working now? So here we specified, right? So for example, you said like, oh, skip this word. So you can specify your analyzer. So that's the job of analyzer, okay? In layman language, that's how I would explain it. Now, oh yeah, there are a couple of more analyzer. For example, we have character filter, you can say HTML strip. So whenever you provide an HTML, it's gonna consider, for example, this would be interpreted as, I always have to show you in the snippets, otherwise it's hard to understand for beginner. So it's broken down to this is a test. So based on the analyzer you provide, for example, the tokenizer is white space. So it's gonna break down into white space. But if you say tokenizer at keyword, this is the entire one word. At index time, you won't break it. I will prove it to you. Let me show you. So it's like, check this out. This is a test, okay? Same thing, if I change that into keyword, check this out. Makes sense, right? How analyzer works. So hope this is clear. Basically, it's used. Analyzers are quite used when you wanna, when you wanna improve the efficiency. Like you want certain words to be skipped at index time. For example, you wanna convert that into lowercase. All that stuff. So that's when the analyzer will come into place. Now, at the end, I would conclude it. I have a nice conclusion here. So whatever I explained you, I've written it in a plain English. So let's read that quickly. What happens when you don't provide an analyzer? The default analyzer will be standard. In simple, what Elasticsearch does, it converts those string or data into tokens for fast indexing. For example, the word two quick brown fox jumped over the lazy bone on the field would be interpreted as this is what it will be interpreted as. But if you provide a custom analyzer and if you want to skip the word the or stop words, you can provide that at an index time. That's what it does, right? So I explained you all of that. So for example, when you index the string, the two quick brown fox, whatever, the same string, this is what will be done. Instead, if you don't say analyzer, what would happen is it would consider the stop words as well, like the word the. I showed you an example, right? So so these are like the Kibana, whatever like commands I was running on Kibana to explain you. And these are the references that I have taken. So hope this will clear a lot of people's doubts on analyzer, how to use an analyzer and stuff like that. At last, I just want to revise one more time how to write your own custom analyzer. I know it's a little bit can be a little tedious for beginners. So you know how to write mappings, right? So you can provide analyzers. So if I don't want to specify my custom analyzer, I can simply say your stop. So this means that you're saying Elasticsearch to use the built-in stop analyzer. If you don't want to do that, you can specify your custom analyzer and then you can define your analyzer. So whenever you want to define analyzer, it is inside analysis. And then you have an analyzer, which is again a JSON.
right? And which takes the name of the analyzer and it takes all the attributes here. For example, filter, tokenizer, type should be always custom because it's a custom, and then whatever filter you define, your user defined filter, you would basically define that below the analyzer right here. I would highly encourage you guys to use Kibana because for beginners it's pretty good. It helps you to write queries, so gives you like automatically snippets and all that. So yeah, I hope you have enjoyed this tutorial on Elasticsearch Analyzer. I tried my best to explain this in an as easy as possible because a lot of people are complicating these things, right? So I just wanted to make it very, very simple for beginners or people who are learning this for the first time.
Well, thank you so much for watching this video, and I hope you have enjoyed a small walkthrough on Elasticsearch queries. And if you did really enjoy this video, please kindly give me a like on the video because it's very, very hard to create content. It takes a lot of effort and time. That's it. I hope you guys have enjoyed it. If you have any more questions, write me an email, and if you have write me an email and I will get back to you. And as usual, guys, keep smiling, keep coding, never give up, and see you guys in the upcoming videos.